a system of linear inequalities is when you have two linear inequalities. And we want to know, find which points in the plane fit both of these inequalities. For example, y greater than 2x and x plus 2y is less than 6. Okay, y greater than 2x, it has a boundary line 2x, not included, color above and to the left. X plus 2y less than x, dotted boundary line. This one here, this half of the plane. Now, if we want both of these to be true, what we must do is find the overlap, the intersection of these half planes. And this is what it looks like. It looks like a quarter of the plane. Now, I have a strong request. When doing this kind of problem, color in only the overlap. I've lost count of how many times that someone color in left of this plane and left of this line here and below this line here. And so you get 3/4 of the plane, and no, that's not the answer. It's only this 1/4 of the plane. This only fits one inequality. This fits only the other inequality. I want the part of the plane which fits both parts of the inequality. So, for example, graph 2x is less than 3y, and 2x plus 3y is greater than or equal to 12. Okay, first, 2x less than 3y, rewrite that as 2/3 x is less than y. Flip this around for x, y greater than 2/3 x. It's a dotted line, you color above, the slope is 2/3 and the y-intercept is 0. So here's the dotted line, y equals 2/3 x. And then we will color in above it. Now we'll color above this line, here and here. And then 2x plus 3y greater than or equal to 12, solid line. When x is 0, 3y is greater than or equal to 12, so y is greater than or equal to 4, here and above. And when y is 0, 2x is at least 12, x is at least 6, so here's 6 by 0, and we point to the right of it. Now, again, we only want to color in the quarter of the plane that is in both half planes. And you'll notice I draw these little arrows here and here and here. I want to find which quarter of the plane has arrows pointing into it. Not this quarter, because this is pointing away and this is pointing away. Not this quarter, because this is pointing in, but this is pointing away. Not this quarter, because this is pointing in, but this is pointing away. But yes, this quarter, because both arrows are pointing into this quarter of the plane. Here we have 3 linear inequalities. Y less than or equal to 1/3 x plus 1. That'll be this line here, and it's a strict inequality, and it's a less than or equal, so it's a solid line through 0 by 1, with a slope of 1/3. And because y is less than or equal, it'll be, we want below this line here and here. Y greater than or equal to x. Oh dear. Here's the y equals x line, and we want above it. And I'm going to have to change this on the canvas, because this should be a solid line here rather than a dotted line. My error. Let me make a note of that. Page 3, 4, 5, 4, 5. Page 3, number 25. Solid. Y greater than or equal to x line. Now, okay, x greater than -3 here. Well, okay, here's the x equals 3 line. Greater than means it's dotted. Greater than, and it's dotted, and we took to the right of it, so we want to color in to the right of this line. So we want to color below this line, want to color above this line, and to the right of this line. And there's 1, 2, 3, 4, 5, 6, 7 parts of the plane these 3 lines divide the plane into. And this triangle in the middle is where all these arrows point inwards. So it's this triangle that's specified. Here we have 5 greater than y greater than or equal to 2. I'll rewrite that as 2 less than or equal to y, y less than 5. Well, here's the y equals 2 line, color above that, and include it because it's a less than or equal. Here's a y equals 5 line, color below that and make it dotted because it's a less than. So below this line and above this line is this horizontal stripe. Now here, y less than negative 3 halves x minus 3, and 3x plus 2y greater than or equal to 2. After a bit of algebra, that's y greater than or equal to negative 3 halves x plus 1. These have the same slope. They're parallel lines. One below this one, so here's a minus 3 halves x minus 3 line, and one below that. Here's minus 3 halves x plus 1 is this line here. We want greater than or equal, so we want above that. But what do you know? There's no point above this line and below this line, so there's no overlap, and it's an empty set solution. Here, in one sense, they overlap. 3y minus 5x less than 0. After some algebra, it's y less than 5 thirds x. So it's this line here, dotted and below. And 5x minus 3y is greater than or equal to 12. After a bit of algebra, it's y less than or equal to 5/3 x plus 4. Solid line, like this. These are parallel, so this is parallel to that. Move it up 4. Okay, so you want points below this line, but also below this line. But everything below this line is below this line, so you just get this half, this part here. Okay. Oh, wait, I forgot. Let's turn it off.